Recently, balancing rate 2 is incur a lot of losses. Here is the preliminary instance report. Here is the interview. Hypnotic monitoring flagged the first signs of an exploit targeting balancing way to composable stable pools. If you don't know the balancer, I will introduce the balancer protocol later. There is a word called composable. Yes, the balancer is an automated market maker like Uniswap, but it is composable. That means you can add a lot of operations before or in the process of swapping. The instance happened in the process of swiping. Yes. I think the root cause is batch swaps. Okay. Batch swaps are here. Yes. So let's return to the official websites. The website is balancer.fi. First, we will see the documents, core concepts. Introduction. Welcome to the Balancer Explain section. Here is the welcoming, and we go to the topic directly. Balancer is a decentralized, automated market maker, like Uniswap. Uniswap is the most famous automated market maker on the internet of Ethereum. The protocol built on Ethereum with a clear focus on fungible and yield-bearing liquidity. Here the fungible means ERC20 tokens, and yield-bearing means if you add some liquidity in some pool, you will earn the swapping fees. And Balancer's success is intrinsically linked to the success of protocols and products built on the platform. There's a lot of other protocols just built on the Balancer. So this attack affects a lot of other protocols. And Balancer v3 architecture focuses on simplicity, flexibility, and extensibility at its core. The focus is flexibility. This protocol is very flexible, and the v3 vault more formally defines the requirements of custom pool. So the flexibility makes the pool more customed. So if you are the developers, you can modify the protocol and shifting the core design pattern out of the pool into the vault. Okay. The balancing pools are smart contracts. Define how traders can swap between tokens. Of course, there are a lot of kinds of pools. One of the kind of a kind of pool is like curve, like stable token pair like ETH and wrapped ETH, or the DAI and USDC, and so on. And the architecture of Balancer protocol empowers anyone to create custom prototypes. As for the architecture, we can explore the architecture. Firstly, let's look at the figure. There are three entities in the smart contract. This is the user or the developer or other smart contracts, and the user will call the router API. The router is the interface for the user. The router can simplify some complicated details, and the router will unlock the vault, and the vault will give the detailed operations. So the real execution environment is in the vault and pool. The pool stores some tokens, so only the operation only the operations are related to the store or withdraw some tokens. The operations will execute it in the pool. Other operations will execute it in the vault. And you can look the unlock and the settle. Actually, the settle includes another operation called unlock finished. This is the detailed overview. Unlock finish. So between unlock and unlock finish, the whole process is atomic. So if one of the steps fails, the whole process will fail. So we can the whole process will revert it. So we can add some other operations. So this mechanism makes the protocol more configurable. And here, let's read the explanations. The router acts the primary interface for accessing the Balancer protocol, offering a user-friendly way to interact with the vault. And the router unlocks the vault. Once the vault is unlocked, the following operations could be executed, which allows it to continue by recording all the credits and the types. The credits means you put some liquidity in the pool. The types means you withdraw some liquidity or tokens from the pool, and generated by the operations like adding liquidity or removing liquidity. or the swaps. The swaps means you can use one kind of tokens to swap another type of tokens. And if you add some liquidity, you have the right to receive some fees. The step 3, the vault processes the operations instructed by router. So the operate corresponds to these operations. The vault can divide the operate into the more detailed operations can be directly executed by the pool or the vault. Usually, forwarding requests to the pools. Yes. For example, in the case of swap, the swap will be involve some pool operations. If you just want to check the amount of the tokens, it is not necessary for the pool to run some operations. So this kind of commands will be executed only in the vault. Here is the understanding. The pool's environment, which is defined in the pool contract, determines the quantity of tokens being either deposited in the vault or withdrawn from the vault. If I deposit some tokens, the token will be out from the vault into the pool. So this kind of swap called exact out means the token will be out of vault, and withdraw means you can withdraw some tokens from the all the liquidity from the pool, and the vault will receive some tokens. So this means exact in swap. Once the required token amounts have been calculated, these amounts are recorded as either credit or debt. If you execute exact out, this corresponds to credit. Another types of swap correspond to debt in the vault. Okay, this is the step 3, and step 4 is the vault returns back the operation results to the router. That means the remaining amount of the tokens will be reported to the vault, and the router settles debts and credits by sending tokens to the vault to pay debts. So if you wanna add some liquidity or want to withdraw your liquidity, you must via this router to realize your goals. And pulling tokens out of the vault to clear out credits. The vault verifies that the router has correctly settled its accrued debts. So if you lend some uh, uh, or the uh, tokens in the pool, uh, the tokens, the staked tokens is accrued. That means as the time flies, you will receive more and more tokens, and the transaction will only exceed if every single debt and credit has been accurately settled. Otherwise, it will be reverted. So this statement express uh, the whole process or procedures are atomic. Okay, the detailed overview. The step one is the same as the simplified transaction flow, and the host means a kind of plugins. Uh, that means you can add some other operations in the step 4, and any smart contract can be served as a router. So you can implement another type of router tailored for some specific use cases. For instance, hooks and pulls can act routers and make calls on the vault. It is also possible to create custom routers to combine vault operations in novel way. The router calls the vault unlock method to opens up the vault to record debts and credits based on liquidity or swap operations. This allows operations on the vault to be combined atomically and still ensure correct accounting. So if you use unlock method, you can add or remove some liquidities. With the vaults are locked, the vault calls back to into router. This means the vault will tell the router you can conduct some other operations. This is where arbitrary logic can be executed. This is the root cause for the instance. The arbitrary operations includes the flash loan. You will find it at let me find the words. Okay. 对 flash loan. Yes. And including any combinations of calls to vault primitives interacting with external protocols. For example, the flash loan. In case of swap action, the vault calls the router-specific action hook implementation, such as swap single token hook, and passes initial function payload. let's look at the step 3. From step 1 back to the router. Continue the regular transaction flow. And the step 4, at this stage, any address gains authorization to invoke the vault functions. This is the operations are expressed here, and invoke the vault functions that require vaults to unlocked identifier by the only when locked. So if you use this modifier, that means only when the unlock method is invoked, you could execute the hooks you are implemented. This mechanism guarantees the accurate allocation of debt and credit. The work will track how many tokens of each kind are owned to it, and how many tokens can be put out of it. And the H refers to the vault. So pull the vaults pull off some tokens, means you store some tokens into the pool. So this means credit. And 5 is each primitive operation performed on the vault might trigger calls on pools. Only when you use some swipes, add or remove liquidities. This kind of operations will trigger the functions calls on pools, like on swap, and calculate invariance or compute balance for the liquidity management operations depending on the operation kind. Not all the operations will invoke the functions calls on pools. These functions calculate the tokens that need to be deposited into or withdrawn from the vault. Proportional liquidity management operations and execution to this rule. The math is solved in the vault level, only here. And the outcomes of these correlations are categorized as either debts or credits, which must be settled at a later stage. Additionally, in the case of liquidity management operations, the required amount of balancer pool tokens, this is the ERC20 tokens, but some operation I will show you. This is the ERC20 tokens. However, it doesn't directly manage the state token. Instead, it delegates these responsibilities to the vault contract. So, if you wanna transfer some tokens, you may use the vault contract. Okay. Here are details. Return the previous descriptions. This is the step 5, and step 6 is execute some smart contracts. For example, mint or burn the balancer pool tokens. After debts and credits have been recorded and shared with the router by the vault, the execution flow is passed to the router here. Return the operation result. This allows the router to be aware of amounts owned by the sender or vice versa. It is important to mention the router contract as the ability to retrieve current debts and credits associated with vault at any point during the execution by calling a specific function on the vault. The user can easily to know the current debts and credits via the router contracts, because the result is returns to the router. And step 8 is here, settle. The router is responsible for settling the remaining debts and credits, which must be done for the transaction to succeed. If ETH or WETH is to be used in the transaction, the router wraps or unwraps either right before settling WETH types. Okay. So if you wanna do some wraps or unwraps, you must before settling the types to do it. When router is done, the vault verifies all credits and debts accrued. The users may pay some fees to the liquidity partners. So the fees are the source of accrued assets. Once verification is complete, the vault is locked again. If all debt has been correctly settled, the transaction will succeed. Otherwise, it will be reverted. Here is the whole process about how it works. On top of basic workflow, pools can be extended with stay-alone hooks contracts that can be leveraged at different stages of the pool life cycle. These hooks contracts can be called either before or after a pool operation. Step 5 here. So the step 5 is highly configurable. Depending how the pool is configured during the deployment. By utilizing hooks, or we can call them plugins, developers can customize and enhance the functionality of pools, enabling the integration of features like oracles or time-weighted average market maker capabilities. The hooks will give the details. Hooks are implemented as standalone contracts that can have their own internal logic and state. So, this is the composable contracts or the composable automated market maker. You can implement the smart contracts as the curve-like pools and other kinds of pools. And there are already some hooks API you can call or invoke. And how pools and hooks are connected. Here are the some connections. And in the end, I will try the features. Open. Let's look at this is the implementation of the smart contract using TypeScript and Solidity as the main languages. Okay. Here is the app. You can connect your wallet. Let me try. Connect. Proceed. Let me try some stable. Here you can add some liquidity, and this is the networks you can select, and add some liquidity. But I don't have the GHO, so I just type some to check whether I can deposit. Avi. This is the another linked protocol. Next, add liquidity, the gas fee, and approve permit, sign token approvals, add liquidity, approve the permit. Let me check. Just $2. Okay. 1 USDT, right? Yes. Confirm. It may be a little bit slow because the block, the time of verifying block is about 12 seconds. And another type of token is USDC, also $1. I just use for the presentation. Actually, you can stake more tokens and sign approvals. Okay, this is my address, the wallet. This may be not my address. Okay, confirm. The gas fee is a little bit high. Give you a sense of cost based on slow speed transaction on your browser wallet. This UI can't access your wallet's transaction speed, so the estimate may be inaccurate. The gas fee is lower. Confirm. Okay, I finished the operation of adding liquidity, staking options to get extra incentives. You just add liquidity and receive LP tokens for pool eligible for liquidity mining incentives. To earn your share, stake your LP tokens. There's no lockup period. You can stake or unstake anytime. So I choose to stake LP token. Potential yield. Next. Okay. Confirm. I know the default may be the negative, so I just for the experience stake LP tokens. So I get another RV. Why? I don't have enough ETH balancing. I need to add some ETH token. So I will experience this function next time. Okay, this is all my content I wanna express. So this is end of the video. If you are interested in the program, you can follow the instructions to have a try. Thank you.